Hello everybody, this is Math with Josh. This is Joshua Phillips. I just really wanted to put a video up right after doing that intro yesterday. So a brief look at why the way I think we all learned how to do subtraction actually works. A big point of emphasis I'm always going to have is on the idea that you should generally have an understanding of why the math techniques you're learning work, not just memorize them and hope you never forget them, and also to think about it. So today I just wanted to talk about how the subtraction method, how I learned, and I think how everyone learned with a tiny bit of variation, kind of where that actually is coming from. So you can see small little word problem here. If we have candy bars that come in packs of 10, and if we have 3 packs of candy bars and then 2 extra spare candy bars, this video is appropriate given that Halloween is slowly approaching. How many candy bars would we have if we have left if we eat 8 of them? So the first thing, let me see if I can find a good color. Let's see if I can find a good color to draw with here. Okay. We're good there, text box. So we're saying, we have 3 packs of candy bars. So there's 10 in there. And as a recurring theme I will frequently mention and laugh about, I'm not getting an art degree. That's never happening. So say we have, our 3 packs of candy bars, and then we have 2 spare individual candy bars, and we want to know how many would we have left if we ate 8 of these candy bars. Now in practice, I'm showing this physically before explaining how our method matches it. If we start counting, we would realize, oh, okay, so if we got rid of 8, we would eat these 2, so these 2 are gone. And then we have to open the next pack. So, the next pack becomes, where'd that color go? We say, this next pack, we have to break that down into, I'm going to draw these just as lines to save us a little bit of time here. Right, we have to break this pack down into 10 candy bars. The first one appears to have gotten a little bit of extra chocolate, which is great for us. And we've already gotten 2, so if we eat 6 more, that would take out these 5 and this 1 on the end here. Actually, let's get rid of the one that I drew badly. And then we would count again, and we would see that this leaves 10, 20 in the 2 packs that are left. Sorry, I forgot to actually cross out the pack and move it down. We would have 2 packs of 10, which is 20 left, plus these 4 loose ones. So that's 20 plus 4, which is 24. So that, physically, especially if you have a small number of objects, is what you would actually do or visualize. But the reason I wanted to make a video on it was to show how we would do this problem without having to actually sort of use a stand-in for the real physical objects, and why that method works. So let's see. I'm going to undo all my drawing here. By the way, while I'm erasing this, you should see some contact info at the bottom. If you have any problems or puzzles you want solved, you can message there. I do math tutoring, including online, if you want to contact. Okay. Same thing. Now, the idea of this video is to show why our method works that we normally use instead of trying to grab a bunch of M&Ms to use as examples. So if we have 3 packs of candy bars and 2 spare candy bars, and the packs come in 10s, we realize this would be 30 in the 3 packs, plus 2 spare, so that would be 32. candy bars. And if we're going to eat 8 of them, we're going to have an upset stomach, potentially. And we're going to subtract 8 of them. Now we go to subtract. As you remember, you go from right to left, and you just subtract the top number from the bottom number. But in this situation, and this is the crux of this video, we realize that 2 is smaller than 8. So we realize we can't subtract by 2. And if you're watching this, what I'm sure you've been taught correctly is, and there's 2 slightly different ways of doing this. The way I was taught is we now cross out this 3, replace the 3 with a 2, we put a 1, and turn this 2 into a 12, and now we say, okay, 12 minus 8 is 4. There's nothing here, so it's like 2 minus 0 is 2, and we got 24, which you may notice matched the answer when we did it physically. And what's really important to see here, if we back up a little bit, this step, what's actually going on, let me use a little bit of a bigger drawing here. So if we have 32 minus 8. Now what's actually going on, and I had to use packs of 10 here, is our number system uses bases of 10. So we have to remember that 32 is 30 plus 2, but it's also, and this is what we're really doing, it's also 20 plus 12. You may ask how I got that. Well, what we're doing is when we cross this 3 out and turn it into a 2, and then we put a 1 here on this 2 and make it a 12, we have moved, we've turned this number from 32, which is 30 plus 2, into this 2 is a 20 plus this 12. So we have, if we think about this with an earlier drawing, we started with 3 packs of candy and 2 candy bars. But because we were going to eat 8 of them, we realized we actually needed to work with 2 packs of candy bars plus 12 loose candy bars, right? This number is 32. This number is also 32, but broken down such that we can subtract 8 from it. And that's why this step works, and why we can now say, okay, 12 minus 8 is 4, because if we take these 12 loose candy bars and we get rid of 6, 7, 8 of them, we'd have 4 left, and we still have these 2 packs left from earlier. So 2 minus 0 is 2, and that 2 is in the tens place, so it's really 20. So that's I wanted to do a first video. I hope for as much feedback as I can get on how I present, whether I'm talking clearly. This was the first little video to think about the reasons and physical analogies of why the mathematical methods we use actually work. And in this case with subtraction, the thing to kind of emphasize that the reason the subtraction method works, or at least a specific aspect of it, is that if you bundle things in tens, and you can think ahead to how this works the same way with hundreds, a bundle of 10 can be broken down into 10 single ones. And so if we're subtracting 8 from a number, if our ones place is not big enough, we can borrow essentially from the other part of the number as long as the total is still correct. So thank you for watching, everybody. Once I've seen this video, I'll think about how to do some better setup for the next one. I welcome any and all honest criticism, no matter how harsh. Thank you for watching. Please get in touch with me if you need anything, if you have problems you want worked on, or you're interested in some math tutoring, and have a nice day, everybody.